Welcome back, everyone. This explainer is brought to you by Forge College. If you're new here, head over to forge.college to check out this and a ton of other Web3 topics. Now, if you were with us for the last explainer on hands-on configuration and resource scripting, you know we got the underlying plumbing of our smart wallet working perfectly. But the user experience? Yeah, it needs a little bit of love. So today, we're jumping into the Interface Patterns workshop. We're going to take those raw, functioning scripts and turn them into a totally polished, project-ready design. Let's get into it.
So here's our game plan for today. We'll briefly cover the usability crisis, draft a blueprint for better UX, and then walk right through the actual build process. After that, we'll talk annotations and rationale, figure out how to pass inspection, and finally, get ready for threat modeling. All right, part 1, the usability crisis, or as I like to call it, fixing the leaky roof. Let's just be honest with ourselves for a second. Web3 mechanics can be absolutely terrifying for normal users, right? It's basically like handing someone a wrench and a manual written in ancient Greek just to turn on their bathroom faucet. In our user testing, we actually got this exact quote. Users said approve sounded like final execution. Just imagine that sheer panic. They literally just want to queue up a simple transaction, but they read the word approve and instantly assume their life savings are about to vaporize into the ether. That panic, that's our leaky roof. But the good news is it gives us a really measurable, testable signal that we can actually fix.
Moving on to part 2, Blueprint for Better UX. Time to make some targeted improvements.
Listen, we aren't painting abstract murals today. We are drafting precise, technical blueprints. And to pass this specific milestone in our design phase, we have one core requirement. 3. That's it. We aren't tearing the entire house down to the studs. We literally just need to implement exactly 3 highly targeted, evidence-based usability improvements to guide our users safely home. Here's a perfect example of what I mean. On one side, we've got that terrifying approve button. On the other side, a clear, friendly action that says confirm and queue. It is such a tiny microcopy change, but honestly, it completely cures that approve versus execute heart attack. We're reducing the user's cognitive load immensely, and the best part is we don't even have to rewrite our entire backend architecture to do it.
Okay, part 3, the build process. Let's roll up our sleeves.
Now, if you're familiar with how we do things in applied Solidity development, you probably know our mantra: prioritize high-impact fixes before sprawling redesigns. Our build cycle here is super tight. We're talking just 90-minute sprints. Step 1, gather your evidence. Step 2, create a lightweight changelog. Step 3, implement those changes. And Step 4, annotate your screens. It's all about short, incredibly efficient loops. So, what are we actually building in those 90 minutes? Well, we have 3 priority fixes. First up, we absolutely need an explicit multisig signing order. Next, a discoverable signer list with clear timestamps. And finally, a completely separate, clearly labeled recovery entry point. The golden rule here is pretty simple. Multisig states and recovery flows should be super obvious when you actually need them, but they definitely shouldn't clutter up your everyday routine transaction screen.
That brings us to part 4, annotations and rationale. Let's decode these blueprints.
Let's face it, a blueprint is completely useless if the building inspector can't read it. Enter the rationale document. This is basically a concise 500 to 900 word artifact that acts as our ultimate handoff tool. Its entire job is to link every single design decision you made back to actual test evidence. That way, when the security team reviews it, they know for a fact that no pixel was placed just, well, because it looks nice. Everything is backed by hard data. And to make sure our annotations are perfectly machine-readable, we use a really lightweight JSON schema. It is wonderfully simple. We use a screen ID so we know exactly which screen we are looking at. We use a region to pinpoint the precise X and Y coordinates on that screen. Then there's a note for our plain language intent, something like replace to prove, and finally an evidence tag to cite our source. This simple structure makes your design logic basically bulletproof and totally transparent to reviewers. But how do we actually label that evidence? We categorize it by the level of certainty. Is it quantitative, like, say, a really scary 42% failure rate? Is it qualitative, like that terrified user quote we talked about earlier? Or maybe it's heuristic, meaning it comes from a security expert's direct recommendation. Tagging it this way tells the inspector exactly how confident we are in each and every fix.
Part 5, passing the inspection. Welcome to the checkpoint.
All right, so here is what the metaphorical building inspector is actually looking for. Number 1, 3 clear improvements must be visually present. Number 2, multisig flow clarity, meaning the signing order and quorum are instantly visible to the user. Number 3, the recovery path has to be fully separated from the main transaction flow. And lastly, your rationale document has to map perfectly back to your evidence. A product manager should be able to look at all of this and understand everything without you having to say a single word. Oh, and please, whatever you do, do not skip the accessibility quick check. Audit your color contrast, check those screen reader labels, and verify your keyboard flow. Honestly, if your primary confirm button blends perfectly into your background color, you're going to fail the inspection immediately. Don't build a beautiful, secure door that nobody can actually see, right? Finally, part 6, ready for threat modeling. It's time to hand over the keys. Look at that. We've successfully turned confusing, raw user data into a totally polished smart wallet artifact. That is absolutely worth celebrating. But before we wrap up today, I want to lock in a few key mental models for you. First, treat the interface as a constant negotiation between cognitive load and security. Second, rely on minimal persistent indicators rather than slapping annoying pop-ups everywhere. And third, treat recovery flows as exceptional paths. They should require a little extra friction, not just be hidden options in a random menu. I'm going to leave you with this somewhat provocative question to chew on. Where does your specific design expose or mitigate risk? I want you to think really deeply about that, because it's the perfect bridge into our next lesson on threat modeling for wallets. Remember, this is all part of the Designing Smart Wallet Patterns module, so there's plenty more to cover. Head over to forge.college to continue your learning journey and dive deeper into this and other Web3 topics. Thanks for drafting these blueprints with me today, and I'll catch you in the next explainer.